for this ellipse problem, they've given us information, and based upon this information, they want us to come up with the equation of the ellipse. So here's what they tell us. They tell us the center is 0, 0, so it's at the origin. They tell us the focus is at -20, 0. And they tell us that we have a vertex at 25, 0. And they want to know the equation of this ellipse. Now with these problems, I can't urge you enough to go ahead and to sketch some or all this information we've been given. That's the best and easiest way to make sure that you do this problem correctly. Because right now, I have to first determine whether this is an up or down or left or right ellipse. Now you can look at these numbers and think about it and probably figure it out. But you know what, just to be safe, smartest thing to do is make a really super rough and quick sketch, and then there's going to be no doubt what we have going on here. So the center is at 0, 0, the origin. I'm not really worried about the focus. Let's say it's got a vertex at 25, 0. Let's just assume 25 is right here. So that means since the center is a 0, 0, if one vertex is a 25, 0, the other vertex has to be at -25, 0. So obviously now, so like the focus would be right here. So obviously we have a left to right ellipse, because that determines which equation we're going to use. So the standard equation for a left or right ellipse is when the x is above the a squared, and in this case the y is above the b squared. So to find the equation of an ellipse, we need three things. We need the center, because the center gives us h and k. Then we need to know a and b. Well, the center is 0, 0. So it actually causes these parentheses to all go away. We know a, because a is the distance from the center to the vertice, 25, and it's a squared. So 25 squared. Now the thing we don't know is b squared. Now we do know the distance from the center to the foci. These are both 20, and you know, we call that distance c, and for an ellipse, we know that c squared equals a squared minus b squared. So if I know a squared and c squared, then I can, from this little equation, find b squared. So c squared would be 20 squared, which is 400. A squared is 625. So if I solve for b squared, if I subtract 625 from both sides, and there you have the equation of this ellipse. Oh, and this problem, they actually ask us to graph it. So let's finish this. So I know it's here, I need to graph the distance b. I need to see what is the square root of 225 as a number. Oh, it's 15. So let's just say maybe 15 is right here, and then minus 15. So there's approximately how what this ellipse would look like. All right, let's do one more where they give you information and they have you figure out the equation, and then they ask you to go ahead and graph it. So here they say the center of the ellipse is at 4, -1. They give us a vertex at 8, -1. So this is similar to the last problem. Once again, I'm going to go ahead and graph this. So the center at 4, -1. Vertex is 8, -1. So I know that this is going to be a left or right ellipse. So to get this vertex, I had to move 4. So if I move 4 in the opposite direction, there's that vertex. So hopefully you can see that, well, since this is now going to be a left to right ellipse, this is my standard equation: x minus h quantity squared over a squared, y minus k quantity squared over b squared equals 1. The center is 4, -1, which means h is 4, k is -1. So if I plug in a 4 for h, I plug in -1 for k, now I know the distance a, because from the center to the vertex is 4. So a is 4. If you square that, it's 16. So just like the last problem, I don't know b squared, but I know that c squared equals a squared minus b squared. C is the distance from the center to the foci, which you can see here. If the center is at 4 and the foci is at 5, that's a distance of 1. So C is 1. So 1 squared equals a squared 16. So b squared would be 15. So there's the equation of the ellipse. Now if I square root of 15, it's approximately 3.9. So I'm going to go 1, 2, 3, 4. So there's 3.9 might be here. 1, 2, 3. So then my ellipse look like that.